Unfortunately, I cannot show you the current version of these devices because of the IP issues of the corporations and stuff. But that technology is existing as a way right now. Before I move further, I want to show you that this approach of projection, of bringing pixels out to the real world, keep replicating to many of my colleagues, many of my friends in MIT as well as other departments in Japan, in Tokyo University. I would love to show some of the work that is done in collaboration with those people. precisely telling you there was not a single special effects or any kind of thing. This was a real short video of what the project was actually. There was two industrial robots which was holding the plates. There was cameras and projectors, which is precisely knowing where that my blank film is, and it's projecting. We call it projection mapping, the technology we particularly use in this particular technology. But you can see that magic is possible. In Indian mythologies, we have seen those magical palaces and all those kind of things. It's possible. We can make it happen right away. But one fundamental another thing started happening. On a lot of my work, I was augmenting the real world with visual data, right? Like I project information on top of that. If you hold a book, I can show you Amazon rating of that book on top of that. Or I can show you live video on a newspaper. Here, we are trying to project whole scenarios, whole world where objects are dropping, objects are popping up, it's levitating in a real world. Then we started thinking that why can we not actually program the matter? Can physical world be programmed by us in some case? Can this chair transform into something else that I want to in some case? Or can in physical, rather than on computer screen I show some objects, why can we not actually create that in 3 dimensions? A friend of mine who was actually involved in this project the most, Daniel, he started working on this project, and I will show you that particular project. machines which were individually controllable by computers in some case, which is running wires and cables and stuff. But what you get out of that is that now you can move the matter. Now you can be either science fiction JDs or whatever the characters that you are imagining to be. But people didn't stop there. Still there is a limitation because this only comes pins from down and something. There is a limitation from that. A colleague of mine, Remy Post in Jinhali, they started thinking that why can we not make the physical object fly in the air? So I'm wearing today Newton's t-shirt, Newton Techfest t-shirt. They thought that why can we not defy gravity in some case? And they come up with this wonderful, simple idea. And that I would love to show you in a similar line of programming matter, the same thing, the theme that we all are working on a similar theme nowadays. And this is one of the work by them.
Zeron is a physical and digital interaction element that floats and moves in space by computer-controlled magnetic levitation. Both the computer and people can move the Zeron in 3D space. Zeron's movements can be digitally manipulated. For example, the human gestures can be played back or rescaled in a physical form. A complex physics system, such as a three-body problem, can be simulated in front of you as a physical reality. It lets you directly put your hand into this 3D simulation space to manipulate its configuration in a tangible way. You can also change the orbit of a revolving planet, which will then change the velocity, confirming Kepler's law. Using the Zeron as a sun, you can simulate lighting of your own world on a small scale. Or create 3D camera paths for rendering virtual scenes of architectural models using Zeron as a camera. When you draw a 3D path in the air and release the Zeron, it is sent back to its initial position and then moved along the previously recorded 3D trajectory. A Hall sensor measures the position of Zeron every few milliseconds, and the electromagnet repels or attracts Zeron based on their distance. This levitator is being carried by the 3D mechanical actuator. The position of the Zeron in the user's hand is sensed by infrared stereo cameras that we built out of conventional webcams. And our long-term vision is to embed computation in physical materials that can directly interact with us. In this way, we seek to redefine the relationships humans have with materials, space, and digital information.
Now I was telling about magic. This is magic. This is technology, and that's what we are ready to see. In our generation, we are going to see these products out in market, and if all of you are going to make that next step. Very last, in a similar line, very recent project from Tokyo University, a friend of mine, Jun Rekimoto, a respected professor from there, and Oichai, his student. The technology behind this is 1975, the standing wave levitation was there. In 2013, the variable wave levitation was there. But this particular team, they made the 3D standing wave very recently. So not only that magnet one ball, but you can put multiple objects, which is really literally flying in the air, and you can manipulate them the way you want. What is happening that there is 4 arrays of ultrasound speaker system. They are creating a 3D area, and it's literally defining the gravity. The standing waves are defining the gravity. Here you can see the dry ice. If you use the dry ice, it shows you the trajectories of the standing wave. So they are putting any components, let's say a simple. So this is taken at 4,000 frames per second using camera. That's how it looks like in a slow motion. That the material, any kind of material can be placed over there. There is a wood piece, a matchstick, part of the matchstick, a screw, a piece of plastic, or even a water droplet. So there is a water droplet flying in the air, and you can precisely control where you want that water droplet in the air. This is a great technology. So the group of the people, including me, they are all excited about how can we make our physical world as interactive as our digital world. My approach was about projection, and I started working on physical part, and many of the other projects that you have seen in a similar line. Recently, I also started working in Samsung. I'm the head of the research for Samsung, and I work with experts from different fields. This is a small portion of the Ninja team that we have over there. And one of the products that we just launched several months before, I will show you one of the very quick video about that.
Tracy calling Hemlock Holmes.
Go ahead, Tracy. Elroy, you're a genius. A regular chip off the old block. 2 up the top.
Get going with the lace pad picker up.
Right away, Michael.
Giant robot, put your laser ray on that tower!
I think Uncle Gadget may be in trouble.
Bones, you and Sue to the transport room. The rest of you with me. We have a job to do.
That's Samsung Galaxy Gear. There was a lot of learning from giving an idea, taking an idea from all the way from paper to your mind to bringing it to real market. There's a lot of challenges and there's a lot of learning. And I can only say about what is the next coming, and I cannot disclose more details about that. But keep your eyes open. In 2 or 3 months, there's something more exciting coming into market, which is our work, my work in some case. With that, I would again come back to that slide, like how do we invent? Is it an accident? Is it need or necessity? Is it solving problems, inspiration, vision, desire to do something? Or all of them? Or it can be something completely different. And I would say that yes, the answer is all of them. It can be something else, something that struck you. Today I want all of you, all of those students came from different universities, even from IIT, to think, what is that drives me? For me it was magic. There was no formula or recipe. There was magic. That word is with me right now. And I want all of you to make the future is today, your future is today. I would say one sentence about that it is by logic that we prove. by intuition we create. Einstein had said a nice word. He said that the world we have created is the product of our thinking. It is like this, it cannot be done, or it's already done, or something like that. But he said that the world that we have created is the product of our thinking, and it cannot be changed without changing that thinking. So think big. Find what is the replacement, what is that word like magic for me, what is your word for making that future starts today. I wish 12 years from now or 13 years from now, all of you come here and give this lecture that I am giving right now. I wish this for you.
Sharing your immense knowledge with us and inspiring us. We now proceed to an interactive session with Sir. Due to unavoidable time constraints, we can entertain only 3 questions. Please keep your questions brief.
Can you put some light on Dr. Kalam's India Vision 2020 and what role you would like to play in that?
Dr. Kalam's Vision 2020 is built by all of us and for all of us in some case. Whichever way I can participate, I can help, I'll be more than happy to do that. I personally think that our country, in specifically the youth generation, I'm not saying you guys know, we are the largest youth. The youth power of India is the largest in the whole world. It's time to show the world that this is India. We are number one. We need to show that. Dr. Kalam's Vision 2020 will only come true if all of us act. We need to act on that, right?
Sir, I would like to know if you believe in teleportation.
Say it again.
I would know that if you believe in teleportation,
Yeah.
do you think it's possible?
So, good question. So, I will tell one small story around this. In my laboratory, there was one professor who told me this story. He said that there was in old time, if some old professors, like very old school people, or they don't know anything about new technology, if they say that this is possible, this can be done in the future, they are right. They are right. It can be done in the future. If the same person of some other thing, he said, oh, this is not going to happen, it's not going to happen, then they are wrong. The point that I am trying to make is that if you dream something, if you can think of something, it's already there. You just need to make it happen. You've already finished the 50 part of the work. Now 50% is just left to implement that. The idea is done in that case. So never think that nothing can be possible in some cases. Then I would not sound like a crazy that okay, anything can be possible or not. Yeah, maybe in future anything can be possible. There is a timeline in some case, there is a progression that happens in some cases. So I will be looking forward for that time when teleportation happens in some case. And to be very precise with you, I'm not sure. IBM research very precisely pass one particular atom from one place to another place, same atoms in some cases. So there is already work happening in that line. So I would just wait for believing that.
Hello. Good evening, Krishnakant Mane from your own Industrial Design Center department here.
I'm not able to see besides you. Okay.
Okay. So just 2 short questions. One is I see that when you showed the case of David in Brazil, the code was open source. So is there some kind of possibility that we have some kind of, I shall not say incubator, but kind of a sanctuary where young innovators can come and innovate and develop things around the SixthSense? That's one question. And another question, slightly professional, is that now that you are in Samsung, a visually disabled person like me can't use touchscreen with great ease. So I have tried text-to-speech technologies. I'm myself a programmer, but with the physical touchscreen and the digital control, is there something you have been doing about it?
Thanks a lot for your questions. So definitely the first question, SixthSense code is open. So it's, if you just search code.google.com/p/SixthSense, you will find all the code. There's actually a lot of work happening for visually impaired people in SixthSense. How can we actually make that technology accessible by speech in some cases? So that's already happening in that case. And to be very precise, a lot of my, not particularly me, but a lot of my friends and colleagues in MIT are very much interested in this particular field of helping, making technology help accessibility issues. So I would definitely ask you to look more into MIT Media Lab and say particular search there, and you'll find a lot of work, a lot of prototypes even in early pilot stage in this case.
Once again, thanks sir for spending his valuable time with us, and congratulate him for whatever he has achieved so far and whatever he is yet to achieve. I would request one of my colleagues to present sir with a memento and a token of our gratitude.